configuring and using Terraform providers. Unlock the power of infrastructure as code with these essential tools. Terraform, developed by HashiCorp, is an open source tool used for building, changing, and versioning infrastructure safely and efficiently. It enables users to define and provision data center infrastructure using a high-level configuration language known as HashiCorp Configuration Language, HCL. One of Terraform's most powerful features is its extensibility throughout the use of providers. Providers are plugins that Terraform uses to interact with cloud providers, IaC providers, and other API. Understanding Terraform providers. Providers in Terraform serve as a bridge between Terraform and the various services it manages. Each provider offers a set of resources type and data sources that Terraform can manage. For example, the AWS provider includes resources such as AWS_instance and AWS_S3_bucket, allowing users to create and manage AWS resources. These are providers available for the most major cloud platforms, including AWS, Google Cloud Platform, Microsoft Azure, as well as for other services like GitHub, Kubernetes, and more. Choosing the right providers. Selecting the right providers is crucial for your Terraform project. You should consider provider support. Ensure the provider support all the resources you plan to manage with Terraform. Provider maturity. Look for providers that are well maintained and have a strong community or official support. Provider documentation. Good documentation is essential for understanding provider usage and resource configuration. Here is a list of the most widely used Terraform providers. AWS provider, the Amazon Web Service provider, is among the most used due to AWS' extensive adoption in the cloud industry. It allows for managing a vast array of AWS services like EC2, S3, VPC, and RDS. Azure RM provider. The Azure Resource Management provider is used for managing resources in Microsoft Azure. It supports a broad range of Azure services, including Azure VMs, networking, and Azure Active Directory. Google provider. The Google Cloud Platform GCP provider enables management of GCP services such as Computer Engine, Cloud Storage, and Kubernetes Engine. Kubernetes provider. This provider is used for managing Kubernetes resources, including deployment, pods, and policies, making it crucial for container orchestration. Terraform provider for VMware vSphere, widely used by organizations leveraging VMware's virtualization and cloud computing services. This provider manages resources in VMware vSphere environment. Oracle Cloud Infrastructure provider. The OCI provider is used for managing resources in Google Cloud, including compute, networking, and database services. DigitalOcean provider. Most popular among developers for its simplicity, the DigitalOcean provider facilitates the management of DigitalOcean droplets, space, and other resources. GitHub provider. This provider is used for managing GitHub resources such as repositories, teams, and organization settings, making it essential for DevOps practice. GitLab provider. Similar to the GitHub provider, the GitLab provider is used for managing GitLab resources like projects, groups, and deploy key. Cloudflare provider. The Cloudflare provider is used for managing Cloudflare resources, including DNS record, zone, and page rule for website performance and security. These providers are indicative of a broad ecosystem that Terraform supports, spanning cloud computing, virtualization, container orchestration, and version control systems. The popularity and usage of Terraform providers can vary based on the industry trends, organizational preference, and the specific requirement of infrastructure projects. HashiCorp, the creator of Terraform, continuously update and add new providers to support a new evolving landscape of cloud service and infrastructure management. Configuring providers. Configuring a provider in Terraform is straightforward. It's a step-by-step guide to get you started. Specify the required provider. Begin by declaring the required provider in your Terraform configuration. This is typically done within provider.tf file for organizational purpose, but it can be declared in any .tf file. 2. Configure provider settings. After specifying the required provider, you must configure them with the necessary credential and setting. This configuration is placed within a provider block. It's best practice to avoid hard coding credentials in your configuration file. Instead, use environment variables or encrypted secret management tool. Initialize your configuration. Run Terraform init in your project directory. This command prepares your project for use by downloading and installing the specified provider. Plan and apply your configuration. With your providers configured, you can now use Terraform to plan and apply your infrastructure configuration. Best practices. Version pinning. Always pin to a specific version of a provider to ensure your configuration is stable and predictable over time. State management. Understand how Terraform state works, especially in team environments. Consider using Terraform Cloud or Terraform Enterprise for advanced state management features. Sensitive data. Never commit sensitive information like access keys or password to version control. Use environment variables or secret management tools. Modularize your configuration. For complex environments, consider modularizing your Terraform configuration to make them more manageable. Custom providers development. Use the Terraform plugin SDK version 2 to learn how to develop your custom providers to extend Terraform's capabilities. In conclusion, Terraform providers are a cornerstone of Terraform's infrastructure as code capabilities. By understanding how to configure and use providers effectively, you can leverage Terraform's full potential to manage your infrastructure. Remember to follow best practices such as version pinning and secure management of sensitive data to ensure your infrastructure management process is both efficient and secure.